Great. Welcome, everyone. And thank you for sticking with us. It's 10:05, so we're going to start now. My name is Nifemi, and I'll be your anchor for today's event. Today, we are going to be exploring unlocking agility, .NET application modernization from monolithic to microservices. This webinar is organized by Reliance Infosystems. For us to kick off this event, I would like us to become familiar with a few housekeeping rules. First off, this presentation is being recorded for documentation purposes and will be shared with all attendees at the end of this event. We've also had our microphones muted and turned off our cameras for decorum purposes, and would like to let you know that at any point in the course of this event that you may have questions, please make use of the chat window and let us know what your questions may be. We have experts who will get to you in no time. In the meanwhile, we'd like to know where you're reaching us from and would like to engage with you. Thank you so much. Today, you're going to be hearing from two speakers who are with us at Reliance Infosystems, Abdulgafar Abdulmalik, a full-stack developer, and Ugonna Donald Ezema, a senior full-stack developer. Both of them are with us at Reliance Infosystems, and I remain Nifemi, your anchor. In the course of this webinar, we're going to explore an introduction to Reliance Infosystems for those of us who are unfamiliar with the brand. We would look at app modernization, monolithic application, microservices, domain-driven design, event-driven architecture. We'll have a demo to put all of these learnings together, and we'll take your questions and answers before concluding this webinar. Now to who Reliance Infosystems are. We are a leading and award-winning global ICT organization, and we have physical presence in 10 countries and counting. Our primary focus is to help organizations harness technology to meet their business goals. This simply means that we create enduring partnerships with our customers, and we try to align with you so we are not working on separate patterns. We help you to harness technology and ensure that you can leverage or maximize these solutions for your business to advance. So our physical footprint, we have our headquarters in Canada, we have presence in the UK, Pakistan, and UAE. And in Africa, we have presence in Nigeria, Kenya, Botswana, South Africa, Ghana, and other countries counting. This is to let you know that it doesn't matter where you may be, we are not hindered by geographical location. We have agents on ground who are willing to proffer services and solutions to you at any point in time that you may need them. Our company abides by a success outcome philosophy, which revolves around winning with our customers. This is to let you know that we do not address customers or clients as such. We see you more as partners. This means that we are invested in your business and we align with you every step of the way because your success means a lot to us. So we can only say that we have succeeded when we can see you succeed in your desired path. Our work has been recognized over the years by several people and organizations, and we have won several awards to this effect. And I would like to let us know that Reliance Infosystems is the only organization at the moment who has consecutively for the last 6 years won the Microsoft Partner of the Year award in at least one country where we have physical presence. This I consider very laudable. Our partnership is with several organizations, including Microsoft, Cisco, Sophos, Avaya, and Hewlett-Packard. We have a wide array of partnerships to let you be assured that it doesn't matter what service or solution your organization is possibly looking for, you have Reliance Infosystems available to assist you in any way possible that you may need technology. We've also earned the Solution Partner designations for Azure Solutions, Modern Work Solutions, Security Solutions, Business Applications, and Microsoft Cloud Solutions. To conclude this introduction, I would like to introduce you to our success pillars. We have 3 of them on which our solutions are grouped. These are business transformation, operational excellence, and protection assurance. Business transformation is focused on lowering your operational costs, improving your efficiency, and maximizing productivity. Under here, we have solutions grouped into identity and access management, enterprise voice and collaboration, cloud hosting solutions, intelligent building solutions, among others. These are mostly cloud-based that help you to leverage the scalability and flexibility of the cloud. Operational excellence refers to automating repetitive processes and ensuring that your customer engagement is top-notch. We understand that it can be challenging and also time-consuming to ensure that these repetitive processes do not infringe on our daily activities and take us away from focusing on results impactful activities. So we deploy modern enterprise resource solutions, customer engagement, and digital advisory solutions, among others, to boost your operational excellence. Finally, protection assurance. It is not enough to invest in operational excellence and business transformation without or neglecting security. We profile security solutions such as gateway protection, endpoint protection, and penetration testing to enable you focus on running your business and meeting your strategic goals as opposed to fidgeting or worrying about security vulnerabilities. These services are also referred to as rest of mind as a service. So this concludes my introduction of Reliance Info Systems, but I have something for you. By being a participant of this webinar, you are entitled to a free consultation session with any of our experts. As the concerns are regarding .NET application modernization, you're free to discuss with us for us to understand your use cases and know how best we can assist you with our services or our solutions. We are going to be dropping the link in the chat window, but the link is also showing on the screen, and you can type this in and schedule your preferred date and time for us to meet with you. We look forward to engaging with you. At this point now, I would like to remind you that you can use the chat window at any time to ask your questions, and we are eager to engage with you. I would now like to introduce our first speaker, Ugonna, who will be taking us through unlocking agility, .NET application modernization from monolithic to microservices. Thank you. Ugonna, the floor is yours.
Hello, everyone. Good morning, good afternoon, good evening, depending on where you're joining us from. Welcome to this event. Permit me to take control of the slides while I make my way across them. All right. So we've already been told that we'll start with an introduction, and then we'll go forth to app modernization to describe what app modernization is, and then monolithic applications, what they are, how they serve us best, and when to switch over to microservices. Then to domain-driven design, which is an approach to the best approach to actually accomplishing microservices. Then we move to event-driven architecture, a paradigm in software engineering that helps us achieve domain-driven design. And then the labs will be taken over by Abdul Malik, and then we'll have the question and answers for you. We'll respond to your questions during which will be you can post in the chat window. So the case study for this presentation would be Contoso e-commerce. Contoso e-commerce is just an arbitrary or just a makeshift company that we're just going to use to discuss this this app modernization, this presentation that we have for you today. And the labs as well will also be geared towards that as well. All right, so what is the quota for availability today? It's 247,365, which means 24 hours a day, 7 days a week, 365 days a year with zero downtime. And we actually know that this is made easily available to us with adopting cloud. And this alone is not how to achieve that. There has been an introduction to continuous delivery and continuous deployment, and that helps us to achieve these processes with cloud adoption and the promise of some of the resources being available to us up to 99.99% or up to 11 nines after the dot on the right. So it will be best to have the best application, like a cloud native application that will help you serve that purpose, to give you the best of what you need, the best of all that you require for a business to run smoothly. And we all know that change is a difficult thing to actually accomplish because some of us might have difficulty adopting change, so it will be best to actually come with a huge company that might be conversant with this microservice being the topic of the day, and convincing your team on how to actually accomplish that gradually until it's done completely. So with dev software development, there are metrics that are actually available to us. It is firstly deployment, which is the rate at which software is deployed into production. Lead time, which is the duration between developer checking in change and that change being deployed. So if you have a code reviewer, how long it takes for them to review the code and they have them pushed to the cloud for use, you know. And meantime, maybe not cloud, maybe on premise or your traditional hosting service, you know. So the meantime as well to recover will be the amount of time it takes to recover from problem to in production. And change failure rate is the proportion of change that results in problem in production. And in traditional organization, development frequency is low and lead time is high. Stressed out developers and operations people typically stay up late at night to solve problems. But in contrast, DevOps organizations release software quite frequently. Often multiple times per day, and far fewer production issues. Companies like Amazon, they deploy changes into production every 11.6 seconds, and that was in 2014. So imagine what the record would be today. And Netflix, on the other hand, they have a lead time. That's the time for developer to check in a change and have it being deployed of 16 minutes for each software component. So what is that modernization? If you have your application on premise and if you have it on traditional hosting platforms, it's considered to be in need of modernization. If you have it on a large scale, like the application has become quite large and complex, and it's difficult to maintain, with your dependencies being left behind, and your tools that used to develop it are being deprecated, like no longer supported, and you want the best of top of the line technologies that we use to update your tools just to keep your system avoidant of security loopholes. You might need to consider modernization. So it's the adoption of cloud, be it the public, private, or hybrid cloud. You can hybrid being that you can actually still have your application on the on-premise as well as on the private cloud or public cloud as well. So the aim of this process is to enhance the performance of the organization and its technology. It improves the experience of customers as well as the employees, and it speeds up delivery of new products and updates. So you don't have to worry about any of these issues when you have your application on the cloud. Companies like Microsoft, they've invested millions of dollars, with improving your security, with the attempt to improve the security of applications that have been there on the platform. With software as a service being one of the services being rendered, platform as a service, and infrastructure as a service. So there are very particular things that you need to focus on when you're dealing with cloud adoption. So cloud adoption framework, Microsoft's cloud adoption framework, is a comprehensive guide that helps guide architects, IT professionals, and business decision makers to achieve their goals for cloud adoption. So it's well prepared. Like, you have to focus. The core is to define the strategy. They can now follow through with adopting, getting ready, planning, managing, and then governing the regulations, like following through with regulations for GDPR or for those in Nigeria, NDPR. So that's what you need to understand. And also one of the things you need to take note of is that it's also there for the long run of the use, like throughout your experience of the cloud adoption. So if you've been adopting cloud for quite a long while, or just new, you can always refer back to this adoption framework, and you have yourself like with the latest of tools that you use for migrating to the cloud. So the cloud plays a very vital role. Like I said earlier, it provides us with access to top-of-the-line tools and guidance, and enables rapid innovation while reducing costs. So we're going to discuss why microservice being a type of application, and how it is in comparison with microservices, like what the trade-offs are. So we're going to discuss that during this presentation. So with the top of the line technologies, companies can modernize their applications more effectively and efficiently, taking advantage of many benefits that the cloud has to offer. So that's just the best thing that you need to know about cloud. It provides us with access to top of line technologies, security, and as well as cost effectiveness. So you need to focus on just operational expenditure as opposed to capital expenditure. So what are monolithic applications? They are not necessarily bad applications, to be honest. They serve for the best. They serve best for initial conception of ideologies and solutions. A monolithic application and all its function has all its functions compact as one and is tightly coupled. So on the cloud, if the auto scaling is being triggered, like when there's high traffic, it's going to scale up horizontally. So this model, the payments model, the shopping cart model, and the inventory model, they would scale up horizontally as a single instance, and that could hurt your pocket. Being opposed to the need for cost friendliness, like, and it's not hurting your pocket as while you're adopting the cloud. So the entirety of the application would be what will scale entirely, you know. I wouldn't want that. You want something that would help you along the line. But if you're still at the initial concept of your application, then you can adopt monolithic applications before it becomes large, or modular monolithic applications while you're on the start of your business, you know. So characteristics of monolithic applications: all business logic reside in a single code base and single development stack, like C#, Node.js, Golang, Java, Scala, PHP, whatever language you're much more conversant with. It's just a single stack as opposed to microservices. Microservices, on the other hand, you can develop each service with a different development stack as one from the other. And a fix involves multiple changes in tandem. So you have to fix it in total so that it doesn't break another section. When you fix a section of your code, it doesn't, and it attempts to break another section of your code, you have to resolve the issue in total, like, so that it doesn't fail in production, so that the use of all these God classes that are being used, by God class, I mean like a class that is being inherited on almost all of each model. And it's if you implement a change on one side, it will cost you time in delivering process, like delete time, so that to now make you have to adopt change in all of the application itself. So the pitfalls to monolithic architecture, like I stated, for large scale code bases, is not optimal for mission critical applications. You have an application like a computer e-commerce that has high traffic, you wouldn't want to use because your sales might be affected, So, or if you're using like the Wall Street application, for checking trades in stock and other variant entities that I can purchase, So monolithic architecture is not suitable for large complex applications. That has been clearly stated. And that is tightly coupled. The dependencies are tightly coupled, and large code base is tough for developers and quality assurance people to understand the code or deduce any business knowledge that they can from the application. So it's going to be very difficult for them, especially when the people that develop the application will have left the organization and you're hiring new people that will take over, the development process or the maintenance window, during the maintenance window. Sorry. There's also an inability to scale individual components. So it's going to be difficult to scale the components individually. So these are the pitfalls for monolithic architecture. So I believe next would be microservice. So monolithic architecture, on the other hand, as you stated, as you can see, is tightly coupled. That's why it's being depicted with this box here. And microservices is separated. They all run independently of one another, autonomously. That's a key word in microservice. And don't forget to ask any questions if you have them in the chat, so that we have experts on the call that will respond to them. So as I was saying, so what are services basically? They are actually being separated with business business capabilities as opposed to technical capabilities, so that the application would be resolved with domain issues like problem spaces. So that's what we're going to discuss with domain-driven design. So just hold on to your seats and we'll get there. Don't worry about that. So it's actually a best practice to design your application with business capabilities so that to stay strong in the event of change in the business environment and ensure data consistency and integration across all separate data stores so that when you make a change in this data store, you would have to make sure that it's consistent across each of the data stores of each service in the microservice, you know. Because if you find on the sixth, jump into the sixth point, the separation of data storage. So each service should have its own data store. Not all domain-driven designs end up with separate data stores. That can lead you to distributed monolith, or a big ball of mud. So that's just not what you should be avoiding. So for best practices, you should separate the data store and ensure that there's consistency across all the data stores. So, or databases, if you will. It's important to adopt DevSecOps approach when implementing microservices architecture to ensure security is integrated in the development process, at the beginning to actually weigh in on all the assets and find out what you need to do about the security. And that's just what you need to know about that. And team resources will be assigned to one team so they can work autonomously. Like, for instance, Uber, for example, where they stated that when they shifted to microservices, they enjoyed it best because when they were able to afford to pay staff members across the world, they weren't able to stress themselves on having to contact each team and internally to have to discuss the change that they have to make. So they all worked autonomously and had to adopt change and actually improve the features, each component independently. So they don't have any issue with that when it comes to microservices. Then there is a single responsibility principle that should be adopted when implementing microservices architecture. So each microservice should have a single responsibility. So it should be broken down as granular as possible, but not too granular that you have just a password reset and user login as a service on its own. So you should always focus on how the business capabilities work, so that you'll be able to understand that as well as the growth of the business in the long run. So like I stated earlier, each microservice should have its own separate data store, to prevent creation of dependencies. That's actually why it's best to separate the data stores. To refactor your monolith to microservices, you can make use of feature flags, or you can modularize your monolith, like modular monolith. That's been known for a while now, and you can actually use strangler fig pattern and or consider domain-driven design. So that's our focus on this webinar. So domain-driven design, domain for splitting or starting to approach domain-driven design, you have to understand your problem space very well before you start anything, before you can model your domain. So on Contoso e-commerce, we have a payment as a subdomain, offer as a subdomain, shipping as a subdomain, and customer as a subdomain. So each unit in the organization that performs a different activity, or service, or things are as differentiated as they are in the organizational unit, is how the code base should work. So it should come from your business capabilities directed into the implementation of the code base. So payments should be separated from offer, and shipment or shipping should be separated as well as customer. So that's what you should understand about that. So we have a poll that is being generated at the moment. So please do well to engage them in the chat window. So a good relatable model for implementation requires an in-depth understanding of the domain. It's very important that you understand that, so that the problem space will provide you little to no limitations on providing solutions, for that domain that you're actually trying to resolve, in the process of your development of the application. And your bounded context is actually the demarcation of one domain to another. Like, what are the rules that apply, or a ubiquitous language that is used within there to discuss the business of that of the going on, the daily going ons of, or if that's correct, basically, but the daily doings of the application of the business that is to be resolved, or the problem space, basically. So ubiquity of language is very necessary. It should require little or no translation at all. So you don't bring in a development jargon to business people. You have to have a domain expert. So if you're building an accountancy application, the accountant should be the domain expert. So he will be the person that will be the go-to for questions that you'd have, and they will have to sync with the entirety of the teams that exist within that unit. So you have ubiquity of language that are translated into the code base to have little or no misunderstanding and to solve that problem. So business requirement is not alone to solve a problem, as you saw in the introduction. So you need more things to actually deal with succeeding in developing an application. So now we have event-driven architecture, which is a paradigm that promotes the production and the detection and consumption and reaction of events. So we have a producer and a consumer and an event broker. So when a service, like a search service, you're trying to use a search service to search for products, and then the product service is subscribed to that event, so it will respond and return a command or a query to that system that is actually being that produced that event in the first place. So there are queries, there are APIs that are actually embedded in these services. They are either commands or queries. So a command is when you want to make a change in database, and then a query is when you want to just retrieve data without making any change in database. So that's just what those things are. So either of those events can trigger any of those processes in the application. So data duplication is a problem that exists in microservice, and you should be able to resolve it with adopting domain-driven design. Although a school of thought believe that it's okay to have data duplication, so it will allow for data ownership, but with the higher school of thought believe that it's actually an issue in microservices. So you need to, if you adopt domain-driven design, you actually counteract this problem that exists. So, and that means when you have an event that has been emitted by a producer, so the consumer here is subscribed to event A, and consumer B is also subscribed to event A. So it could lead to data duplication in each data store of that service. So that is just a problem that exists. You don't have data duplication and have it. It's not right. It's going to cause to be overly redundant in the system of use. And finally, for a fault-tolerant microservice, you should adopt a circuit breaker pattern, which, just like electricity we have in the house, when it's closed, in this case, it operates normally. It operates as it should. When it's half open, some events are being monitored and requests are permitted. So only some certain requests are being permitted. And when it's open, wholly open, then it's immediate. All requests are immediately rejected. So this is a pattern that you can actually follow through with developing a fault-tolerant microservice. So next up would be the demo that will be taken over by Abdulmalik Abdulgafar. So don't forget to ask your questions. Go ahead to put them in the chat. So over to you, Abdulmalik Abdulgafar.
All right, thank you, Donald. Good day, everyone. I believe it's been a very insightful one from Donald. I'm going to take control now. Please let me know once I have the control. Okay, so I believe Donald has been able to really explain a lot of those things that really matters when it comes to you migrating from monolithic application to microservices. There are a couple of things that you always want to put in place first of all before you make the decision, right? So first of all, you want to consider the people you're working with. It's always very necessary. Do you have the necessary skill sets to move on to microservices, right? Do you have a good grip of your business functions in the first place, right? That you can easily translate them into microservices, right? Are you making use of the right tools, for instance? Are you making use of the cloud? Are you making use of the right set of technologies to do that? Do you have a couple of things in place also, like say you have your CI/CD, for instance? So on this part of the demo, we're going to just look at more or less like the technical parts of the microservices. First of all, I'm going to explore a couple of tools that we're going to make use of, and these are industry leading tools. We're going to make use of container registry, which is hosted on Azure. Azure is our cloud provider for the day. We're also going to make use of Azure Kubernetes service. We're going to see how you can have Kubernetes service on Azure in simple steps with the UI. We're also going to see how Helm can be used, right? Helm is a very good tool for you to basically install all of your services on Kubernetes, right? And then we're also going to see Azure SQL database, which is what we're going to make use of because of it comes with a lot of functionalities and allows us to scale easily without you disturbing yourself on how you want to manually scale your SQL database. Then another part of the demo, we're also going to look at the code base, right? We're going to see how our services are being translated into the folder structure. We're going to see how we translate into that. We're also going to see reasons why a microservice allows us to go with a flexible choice of UI, right? So you can go with, say, you want to work with React or Angular, for instance. Then, like I said, we're going to see Azure ACR in practice, Azure Kubernetes, Helm installation, and we're also going to do a couple of these things with the help of some build scripts in place, so we don't spend too much time on this. These scripts are going to be shared in the chat, so do also ask questions along the line if you have any. We have experts on the team who are going to give you a response to that. All right, so I'll be sharing my screen in a bit. Kindly let me know once you can see my screen. Okay, so first things first, that you want to work with when you're trying to work with microservices, right? We all understand from the explanations that Donald has been able to give, we understand that microservices are more or less like a big box that's been broken down into several parts, right? So you have not just one modded ball, but you have everything broken down into different parts, right? So definitely you have some set of infrastructures that work to handle all of that, right? For microservices, you would mostly want to work with a container-based architecture or a container-based technology or a tool, right? And you want to have a repository to save all of these container images, right? So images are each of your services. So we're going to quickly, we have a container registry here which powers our application. A link to the current application is going to also be dropped in the chat for you to have a look at it and see the demo application, right? So so first off, we're going to quickly create a container registry, right? So for you to create a container registry, you can easily just search for container registry like I've been doing before, right? You see different options on the Azure dashboard, so it's quite intuitive for you to make it up, right? So you'd see, then first things first, you want to select your subscription model, right? This is just to let Azure know where you want to or what you want to use to make your payments, right? And then you go with the resource group you want to make it up, right? The next would be to give a name to your container registry. So this is where all of our images for our different services are going to be saved, right? So let's quickly go with something simple here. So you can say webinar demo. Yes. Okay. So the next thing you want to also consider is to pick the location where you want the registry to be cited at, right? This is very important because it lets Azure to basically like know the closest place to you, right? Because you're going to be building a lot of applications from this registry, right? So you want to get the closest place, and then you also want to compare costs also, right? So for our own case, we're going to go with an H2S, right? Then also you can pick a pricing plan here. Do you want the standard plan? Do you want the basic plan or the premium plan, right? All of these plans come with their own perks also. So the next thing you would want to look at is the networking, right? If you're going to premium plan, for instance, you can easily choose between the public or private access, right? You want to make your registry more or less like publicly available, right? Although we would not really advise that for the sake of security, right? you want your repository to be private, right? So which makes things a lot more secure. And then there's one other interesting thing about Microsoft Azure, container registry of Microsoft Azure, which is the encryption part of things. You see that Microsoft Azure allows you to also bring in encryption, right? So you can encrypt your images easily, right? And this is managed automatically for you by Azure, right? Which is always the best case. But the next, we easily pick up tags. Tags are just ways for us to more or less like recognize the registry or to categorize the registries. That may not be needed, so we can easily go ahead to review this and create the registry. So a bit of validation will go on here, then we should be done. Okay, so we can easily click the create button to create the registry. Okay, so this is currently submitting, right? So that's basically the whole step for you to create the container registry, right? Which is the first step. The next step will be for us to create a Kubernetes cluster, right, within Azure. So Kubernetes cluster just allows to plan a lot of things across, say, the instances we want to make use of, the configuration for our machine, how do we want to go about it, what sort of size of machine do we want to use, right? You see that while we're trying to set this up. So once again, I would search for Kubernetes, right? Kubernetes service. Then we create a new Kubernetes cluster, right? Okay, so like we've done before, we also go ahead to pick our subscription, right? And then the resource group we want to make use of. So I'll go again with the resource group that was used before. Then you can go with cluster presets of configuration, right? So these are preset configurations that Azure already has, right? Depending on the intensiveness of your application, right? You can always go with this or the level of workload, right? But for our own case, we'll go with the dev tests. Your own case might be going with the production standard, for instance, or production economy, which is quite cheaper. So we're going to go with the dev test. Then we'll pick a cluster name, right? So I'll be doing this. Yes. Your cluster name might not necessarily need to be this long, right? You can go with something else much more simple, but just trying to go with best practice of trying to name things around the cloud. Then you go with the region, right? So you can pick a region. So like I said, you go with a region that pays off for you, right? It could be the cost or it could be the closeness, right? So we're still going to go with East US, right? We have our registry also in Europe also. So then with the availability zone, you can decide to not go with any zone, or you can decide to go with multiple zones, right? This just ensures that you have different zones spread across the globe, right? And so it's not a case where you have a client within maybe Asia, for instance. There's something wrong or something faulty with the set of nodes in Asia, and then you don't have some other zones that can help you to go ahead with that. So we're going to go with no zone, right? Then your pricing tier, you go with a pricing tier depending on what you want to go with. For our own case, Azure allows us to make use of a free pricing tier. So, and then you decide how you want to go with your patches, your security patches. This is one of those things that comes with the cloud, right? So patches are always very necessary to make you up to date with the necessary security updates. So the next thing we're going to look at is our node pools, right? We're going to see a bit of the configurations when it comes to setting up our nodes. And this is one of those interesting things about working with Kubernetes. You can easily just go ahead to decide, right? You can declare what is the least node that should be available and what is the maximum amount of node that should be available, right? So we're going to quickly do that here. You can easily just go ahead and decide the minimum number of load, right? So say, for instance, you don't have so much load on your applications, for instance, right? The minimum in this case is just going to be 2 instances, right? With this configuration, with this node size, right? They're just going to have 2 instances with this node size, right? That's 2 node size of 2 vCPU, 7 gig. And then in a case where it's maximum, right, you'd have say 5 node counts here, right? And you can even increase the number of node counts. For our case, we go with 2 and 5. We can quickly update this. So the next thing we want to look at is networking, right? So I believe this is one of those things that really helps you to set the pace of how you want to plan your infrastructure. So the first thing I want to look at here is either I want to enable private cluster, right? For our own case, we're trying to run a web application that's going to be public, right? So we would not necessarily have to take this, right? Then the next thing will be to declare your DNS name and prefix, right? So this is going to help you plan your DNS for your cluster, right? How do you want to address your services within your DNS, right? Then we can go with the network policy also. Calico is the default here. The next thing will be integrations, right? One of those very good things about Microsoft Azure is you have the chance of making use of Defender in the cloud, right? So the same level of security that you have on your local PC, you can also bring, this is also in the cloud, right? So the same level of security is also in the cloud for you. So you can go with Microsoft Defender here, which is also available for a very basic plan. The one other amazing thing is the your insights, for instance, which is very, very crucial, right? So you need to always have one way or the other to pick into your services to know how well your services are doing, get analytics from your services, monitor the health of your services. So by default, you have a couple of tools here that are available for you. You can go with the default logs, right? Or you go with Prometheus, which is also a very popular tool for this. You can also go with Grafana, but all of these are going to be enabled by default. They have some alerting policies here. So I'm going to skip the tags also. So in a couple of steps, you can easily come over here to create your own Kubernetes cluster. So once this is done, I'll hit the create button. And then we'll have this available. Okay. All right, please do also ask questions if you have any on the chat. Someone is going to definitely give you a response to that. So next, we're going to look at we're going to look at how we can do a few steps and then push our application to this infrastructure we created, to this part of the infrastructure we just created. We have some that are currently working, right? We have some copies already, which we have already on the ground. We have a Kubernetes cluster already. We have a container registry already. And we have a DB also, which is available. So the eShop application is this, right? This is the eShop application. It's just basically hosting a couple of things you would want to see from the sample application, right? It has a way for you to authenticate, to log in, a way for you to check the catalog, right? Add stuff to the cart also. So we're going to see in a couple of scripts the link to the repository where the code for this script will be shared to you in the chat also. So the first thing you want to do, basically, if you remember, we discussed about having images, having make use of Docker images, right? So in our own case here, we're going to quickly build our Docker application, right? So quick steps, we're going to do this. Build. So this process is basically just going to help us to take the different images from our different services, bring them together and help us to build them, right? Okay, so this is done already. And one great thing about Docker also is that you wouldn't really waste so much time on changes that have been already in your application, right? So Docker instantly detects the new changes. So I've only made a few changes recently, so hence this reason. So this is fast. So the next step would be for us to tag our images, right? And then push our images to a container registry. So how this is being done, right? This script particularly is going to help us to get these images. We have a list of these images. Get the images, retag them. The process of retagging is just to rename the images so that we can push them to a container registry. Right. So quickly going to do this now. So what this script is going to do is going to get our container registry name, right, which is a unique name for our registry, right? It's also going to require a Docker username and a Docker password, right? So these have been added already as environment variables already. So we're going to hit the enter button. So the whole process is just for the script to help us log into ACR first of all, then help us to push this, the images we just built, right? Push them to our container registry. So while this is ongoing, we can have a look at a container registry which we already have before. This is going to be so if you search for your container registry, ours is Modernization webinars CR02. If you check, you scroll down, check under the services category, you'd see repositories, right? If you click the repositories, you'd see a couple of repositories that we have already. You'd see the name of each of our services. The catalog service has its own repository where you have different versions of the image, right, that you use to work with that basket service. Catalog service, for instance, the identity API. You have a couple of other infrastructure tools like your mobile shopping navigator, which is more or less like your API gateway. They have some other parts like payment API, some webhooks. They have the eShop Web SPA here. So let's check back on the process to see if this is completed. All right, so we currently have this done already. You notice that this was also fast because Docker has a way of realizing the latest changes, only pushing layers that are not yet available. So the next step will be for us to use Helm to install. So if you're working with Helm, Helm is just a simple tool that basically helps us to take each of our services, right? Because working with a very large application that's running on Kubernetes can be daunting at times, right? You have a lot of things that you have a lot of repetitive processes that you want to work with, right? So you just need to keep some variables in place and work with Helm. Helm helps you to install each of these services like a package. You can think of it like an exe package. So this is just going to help you take these images, help you to install them directly, right? You can even version those images also, more or less like versioning your application, right? So we're going to quickly do that here. So this is going to be, so we have a script here, which this is also available on the repository. So this just basically helps us to install this on our cluster, right? So we have here, we need the external DNS, right? We need the name of the cluster, right? We need things like the resource group. This is used to help us to recognize where we want to make this installation, right? And we also need to specify the registry where we want to make the installation from, right? So if you notice here, this is the name of the registry, Modernization Webinar CR02, right? You need the name of the registry, and then you need a way to also log in. So Helm is going to help you to basically just log in, go inside, and they help you to install each of the packages, right? So I'm going to click enter on this. The username and password have been hashed here. So what this is basically going to help us to do is to, first of all, know the DNS, right? Because that's the only way Helm can help you to locate where you want to make the installation. The second thing will be to help us to uninstall the older versions, first of all, right? So it uninstalls the older version for us and then installs a new version for us, the new versions of the applications that we have for us. So you can also do this. You can repeat this for, say, for one application, I'm making use of somewhere around 10 different services, right? You're gonna have maybe hundreds of services also, and then this process is just simple for you. So the installation go on, then we would have the installation. So while this is ongoing, let's have a look at some Kubernetes commands that would be handy. So first of all, we can check the health, the condition of our pods, right? Think of pods as our services, right? Your services are always hosted as pods, right? So Kubernetes can help you take these pods and then replicate them across the cluster, right? Which is one of the beauty of making use of Kubernetes if you want to modernize. So what we'll do is to do kubectl get pods. So this just basically this just shows us the current status of our pods, right? So you can see here that you have a couple of containers that are still in the process of creation, right? If you check the status here, you'd see container creating, right? You'd see the state if it's ready or not. This shows that it's not yet ready, right? You also see the restart here, how many restarts afterwards, right? And then how old that pod is, right? So if we try to visit the application, we would realize that, okay, it's in the process of installation. So we try to run this command once more. Okay, you see that we have more ports that are available, right? We have a couple of them that are already running, right? Some are already available, like this, which is 1/1. It's in a ready state, right? We have this basket data also, which is also available. A couple of our APIs are not yet available. So this is because Helm is still currently in the process of installation, right? So if you see the installation, you notice that we have the webhooks, for instance, that have been installed here. You notice the timeline. So when this is done, we can go ahead to check our eShop application to see if it's back online. Okay, so I believe this is done already, right? So we have the entire installation completed already. So we can check the health of the pods once more. kubectl get pods. Okay, we seem to have everything running at the moment, right? We have the API gateway, it's still trying to come up online, right? We have the second API gateway also is still trying to come back up online. So let's run this command once more to see kubectl get pods. Okay. Another very handy tool is the another command we have here is to check where we can visit the website from. There's a simple command that we can use to get. We have an ingress here. So you can easily type the command kubectl get an ingress, right? This also brings up the list of URLs we can use to access different parts of our application, right? So as you can see, this is going to be the URL we're going to use to access the application. So we're going to check we'll go back to check the status of the pods once more to see if this is ready. Okay, so I believe every one of them is ready. So let's copy this URL and check on the browser. Okay, so we have our application here. It's webinar t-shirts. That's the name of and that's what our Contoso e-commerce is really all about. So I'm going to do a quick login to test a bit of functionality to see if things are working well. Okay, so another thing we're going to do is you notice that we also have a catalog here, so we can go ahead to add stuff to the cart, for instance, right? And the application is back online already. You can have access to your orders. You can decide to log out back. You can also decide to select different brands. For instance, I want to go with the .NET brand, right? I know we might also have other brands, right? We might have maybe JavaScript brand or PHP brand, but I'm going with the .NET brand in this case. So I'm going to click apply, and you have this working quite well and good. So please let us know if you have any questions. I believe that wraps up the demo for today. Thank you very much for giving your time to listen to us. We appreciate the questions. We're available to give you answers. Over to you, Nifemi. Thank you very much.
Thank you so much, Abdul Ghaffar, and thank you to Ubuna Donald, our speakers for today. We have responded to the questions that we have currently in the chat window, but if you still have any questions, please make use of the chat window to drop your questions and we'll respond to them. Earlier on, we got a question on understanding the process of migrating legacy systems to the cloud. Ugona, would you like to elaborate on this for participants who may have missed it?
Yeah, basically, the first thing you could do as a fundamental step would be to modularize your application if it's monolithic. And then you can gradually refactor depending on business relevance, to domain-driven architecture with domain-driven design, like I stated. I don't know if that answers the question.
Thank you. I got the thumbs up notification. So I would like to now reintroduce our free offer to you, because at this point we are coming down to the end of today's event. So if you're interested in migrating, you're probably not, if you need guidance on how to even understand your current infrastructure, or you're already considering migrating to microservices, would like you to make use of your free session just because you are an attendee to this program today. And on this call, we are going to discuss with you to understand your use case. We would know how best we can help you. You may also need something else, and we'll explore all of these and more in the course of our conversation. So I want to thank everybody for taking time out to join us today to understand how to unlock agility when you migrate or through .NET application modernization from monolithic to microservices. On behalf of Reliance Info Systems, I remain Nifemi and I appreciate you. You can follow us on Instagram, on Facebook, on LinkedIn, and on Twitter. Follow us across our social media accounts to remain abreast of all happenings within our organization. We are eager to engage with you at every point in time. You can also send us an email at connect@reliance.systems or send us a message on our website, and our agents will reach out to you shortly. Thank you, everyone. Do enjoy the rest of your day.